So this video lesson is looking at Le Chatelier's principle. So we're going to look at an example reaction, and we're going to look at all the different rules that will apply Le Chatelier's principle. So our reaction is going to be SO3 gas reacting with, producing. So SO3 gas is going to react to produce SO2 gas and some oxygen gas, so O2 gas. Okay, and it's going to create some energy as well. So it's an exothermic reaction. So we're going to have a look at all the different rules that can be applied to determine which direction our equilibrium is going to shift in. So if we change concentrations, so for instance, if we increase the concentration of a reactant, okay, so anytime we increase the concentration of something in our reaction, whether it's a reactant or a product, the equilibrium is always going to shift away from whatever you added. So equilibrium will shift away from what's added. Okay. So what that means is that if we increase the concentration of SO3, we're going to shift away from the SO3, so we're going to shift to the right. So if we increase the concentration of SO3, we will shift right. If we increase the concentration of SO2, so the same reaction, but instead increase the concentration of a product, we're going to shift to the left. We'll always shift away from whatever we added. So we're going to shift left. Okay. Same thing is going to be true even if we increase the concentration of a different product. So say we increase the concentration of the O2 with this same reaction, we also would shift left. We're always going to shift away from whatever we added. Now if we decrease the concentration, so of a reactant or a product, then the equilibrium is going to shift towards what you took. So equilibrium will shift towards what was taken. Okay, so if we look back at our reaction here, if we take away some SO3, so we decrease its concentration, then we'll shift towards the SO3. So if we decrease the concentration for our SO3, then we will shift left. So we'll shift towards the SO3. If we decreased the concentration of one of our products, the SO2, then we would shift to the right. That would be the same if we decrease the concentration of the oxygen gas as well. Okay, so that's one of the changes that we can make to our reaction. We can increase or decrease the concentration of a reactant or a product. The other way that we can make changes to our reaction is by changing energy. And changes in energy actually work the same way. So if we increase the energy, which means we increase the temperature, we will shift away from the added energy. And so this is the same rule as concentration, except when we're looking at a reaction, where the energy is makes a difference. Because we know that in exothermic reactions, energy is a product, and in endothermic reactions, energy is a reactant. So it depends where the energy is. So if we look at our example again, we had our 2SO3 reacting to produce our 2SO2 plus our O2 plus some energy. This is an exothermic reaction. So if we increase our energy, in this reaction, we're going to shift left. We're going to shift away from where we added the energy. And so the energy in this reaction is on the product side, so we're going to shift away from the product, so we'll shift to the left. In this reaction, if we decreased the energy, we actually will shift right. We'll shift back towards what we took. So when we decrease energy, which means a decrease in temperature, then we will shift towards where the energy was taken. Okay, so this rule works the same way as concentration. The only small difference is that sometimes energy is on the reactant side and sometimes energy is on the product side. And so we have to take that into consideration before we decide which direction we're going to shift in. Other changes that we can make to our reaction could be changes in volume. So when we increase the volume, we will shift to the side of the reaction that has more gas molecules. So when we're looking at a reaction, we have to shift to the side that has more gaseous molecules. And so when we're looking at this reaction, our 2SO3 gas producing our 2SO2 gas and our 1 oxygen gas. Okay, this side of the reaction, the reactant side, has 2 moles of gas. This side of the reaction has 3 moles. Okay, so if we were to increase the volume in this reaction, we would shift to the side that has more moles, which is going to be the right side of this reaction. So for this reaction, if we increase volume, we will shift right. Okay, when we decrease volume, reaction shifts, so we'll shift to the side with fewer gas molecules. So if we look at this specific reaction, if we decrease the volume, we are going to shift to the left, because the left side has only 2 moles and the right side has 3 moles of gas. Now this is tricky because you have to make sure that when you're counting the 2 sides of the reactions, you only count the gas molecules. Only the gas molecules count. Now, if you have the same number of gas molecules on both sides, reaction will not shift at all. So it will only shift to a side with more molecules or a side with less molecules. If there's the same number on both sides, we'll get no shift in our equilibrium. Okay, and some changes that will also affect our volume is that if we increase our pressure, we will decrease our volume. If we decrease our pressure, we will increase our volume. Okay, so this we gotta know just so that we can apply the volume rule. So if we have changes in pressure, we know how that changes our volume, and then we use the rule for volume. 2 other changes that do not affect equilibrium position, so will not change equilibrium position, are a catalyst or adding an inert gas. An inert gas would be something like neon or helium, okay? And so they will not change equilibrium position. So no matter how much of a catalyst you add or how much of an inert gas, we will not shift the equilibrium position. And that's it for Le Chatelier's principle.